Dear students, welcome to our class on microclimate and weather modification. This I am going to teach from my first book, that is Principles of Basic Principles of Agriculture Meteorology, written 20 years back. Now, see, in this class we are going to study micrometeorology and weather modification basics, simple fundamental basics we are going to study in this class. Now, see, micrometeorology has been defined as the science concerned with detailed examination on the microscale basis of the physical and meteorological factors that are taking place within the ecosphere. So, what is ecosphere? Ecosphere is the zone just above the crop canopy. This is the crop, just above, just below the root zone. That's what we call it as the ecosphere as far as our crops are concerned. Okay, whether it is a plantation crop, whether it is a cereal crop, pulse crop, oilseed crop. Now, as far as this is the fundamental course is concerned, simplest definition which you get in the bits, the micrometeorology has been defined as the climate of a crop field. Okay, a bit will come. The climate of a crop field is known as dash microclimate. So, for the fundamental course, this is the thing. Earlier I taught for the advanced courses the definition of micrometeorology. Now, see, there are very interesting things as far as micrometeorology is concerned. First, we are going to study in this class, okay, micrometeorology and weather modifications. Okay, what is weather? What is modification? Weather is defined as a state or condition of the atmosphere at a particular place and at a given instant of time. So this is what is the weather. How we can modify it? This is very interesting. Of course, I am the strongest believer that as far as climate change or other food security issues are concerned, micrometeorology and water balance are going to do wonderful, and we the agrometeorologists are going to address this problem with full confidence. That's what I would like to say. Now, see, what is what is the generalized profile of a vegetated surface that we should know in the micrometeorology. What is the generalized? This is the generalized vertical profiles of weather elements. What are the weather elements? Solar radiation, temperature, humidity, pressure, wind, etc., rainfall, etc., etc., etc. Of course, derived parameters are there. Okay, evapotranspiration, like that. Now, see, generalized profiles. This question would come in the basics, so please understand. Now, if you take the net radiation, what is net radiation? The difference between the incoming and outgoing radiation is known as net radiation. Net radiation usually would be positive during the daytime and it will be negative during the night time. Why? Because during the daytime the sun's rays are falling, soil absorbs, okay, going on, absorbing. During the night time there is no incoming, only outgoing. Soil becomes a source. During the daytime sun becomes a source. So that's why. So what is happening with reference to generalized vertical profiles of weather element as far as net radiation is concerned? Once again, I would like to impress upon you, net radiation is the radiation which is the difference between the incoming and outgoing. During the daytime, more of incoming is there from the sun, sun is the source. During the night time, net radiation values are usually negative values because soil becomes the source, and during the night time there is no incoming, only outgoing is there. So now see the net radiation. Sun's rays are falling here on the canopy. It goes on decreasing. At what rate it decreases? It follows the Beer's law. What is the Beer's law? Beer's law states that the relative radiation intensity decreases exponentially with increasing leaf area. What is exponentially increasing leaf area? This is the source. Sun's rays are falling. First layer, second layer, third layer, fourth layer, fifth layer, like that, if we cut it. So, the relative radiation intensity goes on decreasing. This is the first vertical profile with reference to net radiation. As far as wind speed is concerned, as I told, basic physics, the gaseous molecules in the atmosphere is known as air. Air in its horizontal motion is known as wind. Air in its vertical motion is known as air currents. The direction from which wind comes is known as windward. The direction to which wind goes is known as leeward. Okay, like that we have studied. So here the wind is coming entering into the crop canopy from the surface goes on becoming 0 here. So why it becomes 0 here? There are two terms here. So one is the zero plane displacement D. The next one is the roughness parameter Z0. Okay. Now as far as Z0 is concerned, okay, what is the Z0 roughness parameter? What is the zero plane displacement? The zero plane displacement is the height at which the wind speed becomes theoretically zero. Theoretically zero. The wind speed becomes theoretically zero. That's what we call it as the D value. D zero plane displacement D value. So physical obstacles, OBSTCL obstacles. So the wind speed becoming zero because of the obstacles is known as zero plane displacement D, and the roughness parameter we call it as the Z0. Roughness parameter is because of the surfaces, earth surface or other roughness surfaces of the earth or anything. So that's what we call it as the roughness parameter. So the wind speed becomes zero. Why? Because zero plane displacement and roughness parameter. In the advances of aerodynamics, I am going to discuss furthermore. Same thing happened with regard to CO2 content. Same. The way in which wind contains, atmosphere is by definition, atmosphere is defined as a colorless, odorless and tasteless physical mixture of gases enveloping the earth on all sides. So in that there is a wind, in that there is CO2, nitrogen, there is oxygen, everything. So same things is followed with reference to CO2. It goes on decreasing like wind, like solar radiation. Now with reference to air temperature, very interesting thing is that during the daytime the temperature of the crop canopy will be maybe goes on decreasing during the daytime. It goes on increasing during the night time because during the daytime the sun's rays are falling. So canopy gets heated up, it goes on decreasing here. Now, during the night time what happens? This becomes the source. The surface becomes the source. So, it goes on increasing up to canopy height. So, as far as the humidity is concerned, the water vapor content in the atmosphere is known as humidity. It is expressed by relative humidity, specific humidity, mixing ratios, saturation, vapor density, different are there. All things as far as humidity is concerned, it goes on increasing. It's not it goes on increasing as far as during the daytime is concerned, because this is increasing, not decreasing. This goes on increasing because humidity, the water vapor content. So both soil and plants, soil loses evaporation and then plants loses the transpiration combined. Evapotranspiration is a cooling process, condensation is a heating process. So what happens to the humidity? When humidity in the crop canopy during the daytime goes on increasing from the surface to the top. So these are the generalized profiles of generalized vertical profiles of weather elements in a crop canopy. This is what I would like to say beginning. Now from here we go to modification of the microclimate. Microclimate I have already defined. Microclimate is the climate of a crop field is known as microclimate. How we can modify the microclimate? From my book, Basic Principles of Agricultural Meteorology, only I am telling to you. So here, first one is the heat evasion. Second one is the heat trapping. First controlling the heat load. Second thing is the controlling the water. Third one is the controlling the wind. Heat, water and control modification. How we can do? Because this is just basics. Heat evasion. When we need the heat evasion, during the high temperature. Say for example 37, 38 degrees centigrade is in the tropical areas. How we can evade the heat? Simplest way. Also, this is just a crop. Presume that this is a plant. When you keep a screen like this, you can evade the heat. So the heat that is entering, is getting screened. Okay, this is how we can evade the heat. Second thing is that heat trapping. When we need the heat trapping during the winter time. So during the winter time, we need the heat trapping. How we can do it? Say for example, see primary tillage, secondary tillage, and seed bed preparation. Now, this is the eastern side. Presume that this is the eastern side. This is the western side, this is the northern side, this is the southern side. Now, we wanted the heat trapping. How we can do it? If we keep the seeds on the eastern side, during the daytime, 6, 7, 8, 9, 10, 11, up to say 11, 11:30 in the tropical areas, the areas facing the eastern side gets heated up. So, what is happening? The seeds takes the advantages of first, whatever the last night's dew plus initial heating it will take. During several of my practical classes with my brilliant students, I observed that if the surface around 8:15 we start the class, around 8:15 the temperature is 20 this side, just hold your breath. The temperature this side is, if it is 20 here, it is approximately 14. If it is 21 here, same 14, like that, there is a gap of a minimum 5 degrees centigrade even up to 11 o'clock. So, this is how we can trap the heat here. So, another classical example of heat trapping during the winter season is, presume that this is an apple. Presume that this is an apple tree. Now, see apple trees in the Kashmir Valley, in Nepal, in Kathmandu, all these areas, what happens is, the farmers construct walls, eastern side, western side, southern side and northern side. Now, why they do it? During the daytime, sun rays are falling on the western side, western wall this side, western wall during the daytime here. So, they reflect the radiant energy, and the morning low temperatures apple can withstand. Morning low temperature apple can withstand. During the night time, the sun rays start from this side. So on the eastern side wall, the reflected radiant energy protect the apple plant. So this is what I observed in, of course, Kashmir Valley, Nepal and Kathmandu areas when I was working with, when I was working as an expert team member of World Meteorological Organization. Now here we tried to understand so far what is it? Modification of the microclimate. Number one, controlling the heat evasion during the summers by shading. So heat trapping, these are the two techniques that I told. Now, so let us see controlling the water balance. Very simple. How we can control the water balance? By increasing the root zone water. What is increasing the what is increasing the root zone water? Say for example, this is the plant, we put the water here. This is the plant, we put the water here. So we increase the water content of the soil. So the soil acts as a two things. It gives mechanical support to the plant. It also gives nutrients. When you put the water into the, we give the irrigation or rain along with the water in the soil, so the nutrients will go. Now, so increasing the water at the root zone. Say for example, in the tropical area, this is what I have my experience with my students. Whenever we conduct the experiment around 8 o'clock or 8:30 when we start to micrometeorological experiment. Now, see the temperature of the soil with an infrared thermometer, say around 20 or 21. When we put the water, the temperature reduces by at least 2 to 3 degrees centigrade within a span of 5 minutes. So that is how we can increase the root zone water content, thereby the microclimate modification. Now, see, next thing is the evapotranspiration. What is evapotranspiration? The combined loss of water, both from the combined loss of water, both from the soil and transpiration from the plant. Combined, we call it as the evapotranspiration. How we can control the evapotranspiration? By spraying some anti-transparents so that the stomata are closed, by regulating the canopy structure, removing some alternate plants, so like that we can control the evapotranspiration. We can modify the evapotranspiration, controlling the water. And third one is the controlling the winds. How we can control the winds? Wind, as I said, as far as definition is concerned, air in its horizontal motion is known as wind. So wind breaks, shelter belts. Please subscribe to my channel, Agronomy, Farmers and Rural Development. In the wind chapter, I had given what are the advantages of wind breaks and shelter belts. So this is how heat or temperature, modification of the temperature, heat evasion, heat trapping, increasing the, as far as water is concerned, increasing the root zone water, and then evapotranspiration, controlling the wind is concerned. Now, so let us try to understand in this class itself how we can modify the climate both at micro and topo scale. Both at micro and topo scale. Topo scale means local scale. Micro I have already defined several times. Topo also I have defined from my book only. I would like to just enlighten the diagram which I had drawn is earlier. This diagram is also from my book, Basic Principles of Agricultural Meteorology. Now, so as far as modification at micro and topo scale is concerned, because this is the basic stuff. Only the modification of the solar radiation. Second one is the modification of the temperature. We try to understand. First one, as far as the modification of solar radiation is concerned, we can do like this. Say for example, we wanted to increase the absorptive capacity of the soil. We wanted to increase the absorptive capacity. So how we can improve the absorptive capacity? Say for example, this is the organic matter, this is the soil. Now you put the organic matter. So soil becomes a bit darker so that the soil absorbs more heat, so that the solar radiation that is falling in increasing the ground heat flux. We can increase the ground heat flux. So, controlling the solar radiation first by absorbing more of solar radiation. Similarly, we wanted to reduce or evade the solar radiation. How we can evade the solar radiation? We can evade the solar radiation by this technique. Take some white powder like this, you put it like this, so that you can evade it. Another thing is that you can put some sort of aluminum foils. That's also one of the techniques. This is how the modification of the solar radiation can be done. Then modification of the temperature is concerned, we can do very, very interesting things as far as temperature is concerned. One of the best things as far as the temperature reduction is concerned, simple, don't laugh, just give the irrigation. Temperature is reduced, so we modified the soil temperature. How the soil temperature is, say for example 30 degrees centigrade. If we give the irrigation in the morning or in the evening, okay, morning around 10 o'clock, soil temperature is 30. Just you go for infrared thermometer, okay, then the soil temperature reduces by 10 degrees centigrade in 10 minutes. How the 20 degrees centigrade, 30 degrees centigrade soil, when you give the irrigation, it goes on reducing up to 20 or 21. This is the first technique. Second technique, see, some sorts of mulches we can use it. What are the mulches? Mulch, soil itself becomes a mulch. So when we plow the field, if intercultivation, primary tillage, secondary tillage, seed bed preparation, okay, we have gone for the crop sowing, germination, emergence, crop has come to vegetative, mid-vegetative stage. Now, in between the rows, there are some weeds. While you are going for weeding, hand weeding, so you disturb the soil surface. Once you disturb the soil surface, this is what we call the soil mulch. What is the advantage of soil mulch? The capillary water from the soil, capillary movement is broken when once you disturb the soil in between the rows of the crop. That is how we can we can modify the temperature of the field. So these are all the things as far as the surface geometry is concerned. One of the techniques is surface geometry. So selection of the sowing windows, selection of the direction of sowing across or along. So this is how surface geometry also helps in modifying the microclimate. This is what I would like to say. once again I would like to impress upon you, we have tried to understand what is microclimate. So what is the modification of the, what is the generalized profiles of the generalized vertical profiles of the weather element. Second, third thing is modification of the microclimate. 3, modification is heat evasion, heat trapping. Number 1. Number 2, water, increasing the root zone level of water, and evapotranspiration reduction. Third one, we tried to understand wind. We can control it by wind breaks and shutter. Finally, we tried to understand modification of the micro and toposcale. That's how we try to understand modification of the solar radiation, modification of the temperature. Thank you very much for your patient hearing. May God bless you.